Hello and welcome to this 15th Algorithm Selection and Development lecture in this course, Master in Artificial Intelligence. So, in this section on researching, selecting, and developing appropriate algorithms to become a successful engineer, we will now talk about how to consider the interpretability and explainability of the selected and developed model, right? So, let's take a look at that. So, we are now ready to consider interpretability and explainability, basically for applications requiring transparency and trustworthiness. And we are now ready after having considered many steps in this section, right from researching to selecting to developing and training the models, etc., and optimizing as well. So let's now look at how to do this. So how to consider interpretability and explainability of selected model. Now you can use techniques like various techniques. Now what are the various techniques? So you can look at feature importance analysis as one set of techniques, and we will talk about that. Then there are model interpretability methods like SHAP value and line, and there are attention mechanisms that you can use in deep learning models to provide insights into model predictions, right? So how to use feature importance analysis to provide insights into model predictions? Any thoughts? See, feature importance analysis is a powerful technique, uh, basically used to understand which features or variables in the model are most influential in making prediction with the model that you have picked up, a machine learning or deep learning model. Now, what it does is it provides valuable insights into how the model works and what factors are driving its prediction. So, what are the key features or variables that drive its prediction? Now, so what is the approach that we can use? So, let's look at a general approach for using feature importance analysis to gain insights into model predictions. So, what is this general approach that we can use to find feature importance or importance of the features to provide insights into model prediction? Let's take a look at the steps that we need to take. First, you need to start by training your machine learning model using your data set. This could be a supervised learning algorithm like decision tree, random forest, gradient boosting machines, or any other algorithm for providing feature importance scores. Having trained the model, then you need to calculate the feature importance scores. Now, different algorithms have different ways of calculating feature importance. For example, feature importance can be inferred in decision trees from how much each feature decreases the impurity in the tree nodes uh, or errors in the tree nodes to make a better prediction. In random forest model, the feature importance can be computed by averaging the decrease in impurity over all trees in the forest, right? And feature importance can be calculated in gradient boosting machines by the total decrease in the loss, a mean squared error attributed to each feature across all trees. And in linear models, coefficient of the feature can directly indicate the importance. Having calculated the importance of the features, then you need to visualize the feature importance. So you can visualize them to gain insights. Common visualization techniques includes uh, plotting feature importance scores as bar using bar charts to easily compare the importance of different features. Visualizing can also be done using the heat maps that can help identify patterns and correlation among features. Then scatter plots can also be used to visualize relationship between feature importance and other metrics such as feature values or target variable values. So these are some of the ways you can visualize the feature importance. After done the visualizing, you need to interpret the insights. So analyze the visualizations here to interpret the insights gained from the feature importance and other matrices such as you know uh, So such questions can be, you can ask these questions. Now, basically three questions you need to ask to interpret these insights. Which features have the highest importance scores? Obviously, these are the most influential features in making the prediction. Are there any surprise or unexpected results? For example, are there features with low importance scores that was expected to be important? And last question that you could consider is, are there any correlations or interaction between features that influence their importance? Having done that, you need to validate the insights. These validate insights gained from feature importance analysis, and this you can do by examining how well they align with domain knowledge, or by conducting further experiments or analysis. Now, this could include testing the impact of removing certain features on model performance or conducting sensitivity analysis, right? And finally, you need to iterate and refine by using the insights gained from feature importance analysis to iteratively improve your model. This could involve the feature engineering, which we will talk about in a separate section as such, selecting subsets of features or refining the modeling approach based on the importance of different features. By following these steps, these generic steps, you can leverage feature importance analysis to gain valuable insights into your machine learning model's prediction and improve its performance and interpretability. Right. So, having looked at the overall model, the six-step model let's look at how to train the model for feature importance analysis to provide insights into model prediction. So, how to train the model? So, you start by training your machine learning model using your data set that you have. Now, this could be a supervised learning algorithm like decision trees, random forest, or gradient boosting machine, or any other algorithm capable of providing feature importance scores. So, having looked at in brief the generic approach to determining feature importance, what do we do next? We will come down to specifics now, and we will look at how we are still looking at how to train these models, and we will look at how to train the decision tree algorithm for getting feature importance in the next lecture. So thank you so much for watching this 15th algorithm selection and development lecture in this course, Master in Artificial Intelligence. I hope you're continuing to learn new things, continuing to enjoy. And I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer a question. And download the PDF file to take a look at anything that is of specific interest to you.